Alright, Algebra 2, this is your second video for your second assignment, which is a beginning of the factoring review where we're going to start. So we're going to start off with, I completely forgot something, that's okay, we'll make it work. Don't want to restart this video, even though it's only 20 seconds in. Before we get to these ones, I forgot that I put greatest common factor. Oh, why is my color changing? Keep hitting it with my hand. Okay, forgot that we talked a little bit about greatest common factor. All right, which means, let's give an example. So, making up a problem here, making up a problem here, making up a problem here. So let's lay out this problem right here. At this point, there's not a lot of methods we can go with this problem, try to factor it, right? Most of our factoring methods are quadratic trinomials, so they need to have an x squared as the highest power. This one has an x cubed. Usually when we do something that has an x cubed, we're probably looking at sum of cubes, difference of cubes, or we could be looking at like grouping, which we'll talk about. We'll talk about all these over the next few weeks. But right now I have no way of going at this because none of those are going to work. So what we're going to do is called the greatest common factor method, which means you look at all three terms and you ask yourself, what do all three of these have in common? Well, when I taught you, when we did it during the year, I said, look at the numbers first. What do 6, 12, and 8 all have in common? What are they all divisible by? They're all divisible by 2. So I know my greatest common factor here is going to start with a 2. And then you go back and you make sure, do they all have the same variable? They all have an x. This one has an x cubed, this one has an x squared, this one has an x. So that means that they all have an x in common, but an x to what power? My rule was, as long as they all have that x, then you're going to take the smallest power that occurs. Okay? In this case, that's this guy, x to the first power. And we do that because we can't take out an x squared because this doesn't even have an x squared to take, right? It only has one x. And I can't take out an x cubed because this one only has two x's and this one only has one x. So the thing that they all have in common is at least one single x. So I'm able to take out a 2x. So that is my GCF. That's my greatest common factor. But you can't stop there. You got to tell me what you left inside once you took out that 2x. And when we did this in class, we divided every single term by what we just took away from it. And this is our exponent rules again. So 6 over 2 is 3, but when I divide, I subtract powers. So 3 minus 1 is x squared. On the middle one, 12 over 2 is a 6. X squared over x to the first. When I subtract, I get 1, so I get 1x. And then on the last one, I get 8 over 2, which is 4, and my x's cancel. Okay, so if they cancel, I don't put them. All right, so that's my answer. I'm going to erase this. It looks weird now. There we go. That's my final answer. That's how you factor GCF. You take out what each term has in common, and then in parentheses, you got to tell me what's left. What did you not take out? What was not in common between each term? Okay? And then from here, we could use another method, and we did this in class. We may get to it in our review. I can now factor this again, probably. And if not, I'd use the quadratic formula. Okay, but I don't know. We're not going to do that right now. I just want to worry about GCF factoring itself. So let's do a few more GCFs. Why do we do that? Let's do that. Let's do this. Something like that. Alright, so these problems are kind of excessive. This one was This first one was a good example of what you'd probably actually do with GCF. This is an excessive problem that I'm just trying to make sure that you guys are understanding what exactly is getting done here. So looking at this problem, you look at the numbers. What do 8, 10, and 4 all have in common? Well, they all have a 2 in common. They're all divisible by 2. Not a lot of originality there. Okay, so then I look. They all have an x. Right? So I take the smallest, which the smallest x is x cubed. Then I look. Each term has a y. So I'm going to take the smallest, which in this case is y squared. So my GCF, my greatest common factor, is 2x cubed y squared. But I'm not done. Again, I have to decide what I left inside. What did they not have in common? So I divide every single one of these by my GCF. So again, when you divide, you subtract powers. Make sure you're actually dividing the normal numbers, the coefficients. So 8 over 2 is 4. X to the 4th over x cubed is an x. Y squared over y squared, that cancels. So it's gone. Again, when it cancels, don't put it. The next one, 10 over 2 is a 5. X's cancel, and I get y cubed over y squared. I subtract 3 minus 2 is just 1y. And then the last one, 4 over 2 is 2. X's cancel, y to the 4th over y squared. 4 minus 2 gets me y squared. So that is our final answer. That is factor GCF. Okay, so that's how we did GCF factoring. You decided what did they have in common. Okay, all 3 terms, all 2 terms, all 4 terms, whatever it is. Okay, take that out and then tell me what they didn't have in common. What were you not able to take out? That stays inside the parentheses. So that's GCF. So now that we got that covered, let's go back to the other factoring review. Let's quickly get through this. We got about 7 minutes. Okay, so now we're talking about our first method we learned, which, I don't know, I'm not very good with names. I called it the normal method, and then I started calling it the reverse foil method, which is probably the better name to use. Okay, so reverse foil method. You're only going to use this method if you're dealing with a quadratic trinomial, meaning x squared is the highest power, and there must be 3 terms. And you cannot have a number right here. Okay, you cannot have a number in front of the x squared, which I just wrote something there, but the iPad's messing up. Come on. Catch up, catch up, catch up. Waiting for it to catch up. If it doesn't, okay, there we go. There we go. There's no number right there, right? It's just an x squared. Nothing there. I put a big old circle in green to show you that there's no number there. All right, so it's got to have 3 terms. It's got to be a trinomial. It's got to be x squared. It's got to be quadratic, and it's got to have no leading coefficient, meaning it's got to be no number in front of my x squared. It's also got to be in this order: x squared, then x, then constant, as being standard form. Okay, so the reverse foil method, this is what we do. We look at the last number, and we find factors of 6. So 3 and 2, 6 and 1. Okay, you're going to set up 2 parentheses. Okay, we know how, we just foiled in the last video, right? So we should have 2 sets of parentheses, and since this is an x squared, I know that I probably multiplied an x and an x together to get there. Okay, so you can set up these parentheses with the variable in front on every problem, right? That's what it's going to factor into reverse foil. So like this one, again, I can set up my 2 parentheses and put an x in the front. I know it's going to foil back into this, or reverse foil back into this. It's going to factor into this. So again, I look for factors of this last number. Now, these factors also need to add to be the middle number. Okay, or subtract, it depends. Okay, so you look at your factors. Is there any way 3 and 2 will ever make a 7? when you add them. No, no way. 5, you can get a 1, you can get a negative 1, you can get a negative 5, depending on signs, but 3 and 2 are never going to make a 7. So 6 and 1, that's my answer. Now I got to figure out the signs. My rule that I told you guys is the bigger number, so of these two, the bigger number is 6, is going to get the middle sign. And this is what I mean by middle sign. That one right there in front of the X term. So this is going to be a plus. And then the last one, you got to use a little bit of, the reasoning. If I have a positive 6, what kind of 1 is going to get me to a 7? Minus 1? No. 6 minus 1 is 5. I need a 7. So 6 plus 1. And it's factored. That is our reverse FOIL method. A couple more. This one, I need factors of 30. So 6 and 5. 15 and 2. 3 and 10. 30 and 1. Okay, got all my possibilities. Now I need these to turn into an 11 when I add or subtract them. That ain't gonna make an 11. That ain't gonna make an 11. Right? Just start thinking of what I could get. I can get it with the first one, 30 and 1, I can get 31. I can get 29. I can get negative 29. I can get negative 31. But no matter what, how you shake it, how you cut it, 30 and 1 is never going to make an 11 when I add or subtract it. Neither is 3 and 10. Neither is 15 and 2. 6 and 5, that sounds good though. All right, 6 and 5 can make an 11. Follow the rules. Bigger number gets middle sign. So the 6 gets a positive. And then what kind of 5 do I need in order to get it a positive 11? Do I want 6 minus 5? Nah, I want 6 plus 5. And that problem's done too. Okay, 2 more. Couple more actually. See how many we can get in the next 3 minutes. The next one, I need factors of 24. Again, go ahead and start up your 2 parentheses. Put your variable in the front. All these are x's because I'm not original. It can be any variable though. Okay. Factors of 24. 6 and 4. 8 and 3, 12 and 2, 24 and 1. Now I need them to add or subtract to get a negative 5. So nah, yes. 8 and 3. 8 and 3 can add or subtract to be a 5. So 8, 3. Bigger number, 8 gets this sign. And then what kind of 3 do I need? Would negative 8 minus 3 get me a negative 5? No, that gets me a negative 11. So I need negative 8 plus 3. That gets me a negative 5. And if you want to check yourself, add your 2 numbers you chose. Negative 8 plus 3. It adds to get the negative 5 that I had in the middle. And then it needs to multiply to get the last number. Right? So negative 8 times 3 is negative 24. Boom. Got it right. If you want to check yourself. Okay? A couple more. This one. Set up your parentheses. Put an X. Alright, I need factors of 12, 4 and 3, 6 and 2, 12 and 1. Of those options, which one is going to get me a 4 if I add or subtract them a certain way? 12 and 1, no. 4 and 3, no. 6 and 2, can. Remember, bigger number, which is 6, in this case, gets the middle sign. And then what kind of 2 do I need in order to get a 4? Would I want 6 plus 2? No, that gets me an 8. I need 6 minus 2. Again, if you want to check yourself, 6 minus 2 is 4. 6 times negative 2 is negative 12. Cha-cha works. Oh, we got to go quick. Factors of 35. Holy cow. Right off the top of my head, I know it's 7 and 5. Again, bigger number gets middle sign. In this case, what kind of 5 do I need? Would I want a positive 5? No, because negative 7 plus 5 is not negative 12. Negative 7 minus 5 would give me this negative 12. And if I multiplied them, negative 7 times negative 5, it is 35. Alright, we're good. We're done. I have to call it quits. If you guys have any questions, email me, message me, whatever. Get a hold of me. Papers are due Friday. Miss you guys. Hope you guys are staying safe. And I'll see you soon.